This lesson is 8.1 Relations and Functions. Our characters, Rocket and Arrow, will be introducing you to relations and functions using their amazing function machine here. Now, we're going to use the input-output table that we used in class last time. And we're going to take an input here and put it into the machine. Now you can see Rocket has the 0 from our input machine. And he dumps it into the machine, and out pops a -3. Now Rocket thinks that what happened to his 0 is that 3 was subtracted from it. So he's saying the function of his machine on 0 equals 0, or his input, -3, and he got a -3 as an output. Arrow agrees. Now they want to test it with the next input. The next input is a 2, so Rocket puts a 2 in the function machine. Now you can see he's thinking a -1 is going to come out, because if we take the function of 2 and we take 2 minus 3, we should get a -1. But look, a 5 came out. So our 5 was the output, not a -1. What? What happened? Says Rocket and Arrow. So let's see if we can figure it out. Well, Rocket knows that subtracting 3 is part of it, because when 0 was part of the input, -3 came out. So there has to be some element of subtracting 3. Now he also knows that the property of 0 is if you multiply anything by 0, you get 0. So there must be something being multiplied for us to have gotten a 5. So what Rocket does is he takes the -3 and he adds it to 5 to get 8. And he says, well, what times 2 gives me 8? That's 4. So now he's going to readjust to the function of 2 equals 4 times 2 minus 3. That gives us 5. 4 times 2 is 8, minus 3 is 5. Now let's readjust that up here. We've decided this one isn't correct because it didn't work with our second set of data. So let's say the function of 0 equals 4 times 0 minus 3. Well, 4 times 0 is 0, minus 3 is -3. So now Rocket feels like he has a better idea of what his input-output machine is doing. And so he writes himself a little equation, or function. He lets x equal the input. So the function of his machine on x, or any of these inputs, would be 4 times his input, or x, minus 3. So let's test it with the next number. If I put a 3 equals 4 times 3 minus 3, I get 12 minus 3, or 9. So, yep, that works. Now if you look at the last entry in our table here, it's a 10. So Rocket should be able to put a 10 in his function machine. His function machine does its work. 4 times 10 is 40, minus 3 gives us 37. So now we know the answer to that part of our input-output table. So now let's look at a definition of what we're doing. The numbers in our table are what we call a relation, or a pairing of numbers in one set, the domain or possible set of inputs. So basically what that's saying is an input is what we call the domain. So any number in our input column is considered part of the domain for this specific relation. the range or set of possible outputs. Now let's look at that. So that means that the outputs are titled the range. So all of these are the range. For a relation represented by ordered pairs x, y, the inputs are the x-coordinates and the outputs are the y-coordinates. So this is another way to look at each of our columns. Our input column can be labeled x, and our output column or range can be labeled y. So that means that we can take our table here and we can write our data a couple of different ways. One, we could make a table x and y. We've got 0 is the input, or x, -3 is the output, 2, 5, 3, 9, 5, 17, and 10, 37, because we decided the output when we put in 10 was 37. So this is another way to write the same information. Another way to do it is to make these ordered pairs. So we could have 0, -3, 2, 5, 3, 9, 5, 17, and 10, 37. This makes it easier for us to turn this into a graph or scatter graph on a coordinate plane. This is even another way to represent our data. Now sometimes you create what's called a mapping diagram, and you take your inputs and you list them in a column, so like we did here, but they need to be in numerical order. So 0, 2, 3, 5, and 10. And then we take our outputs, -3, 5, 9, 17, and 37, and we map them. So if we look at our first ordered pair, 0 is mapped to -3. In our second ordered pair, 2 is mapped to 5, 3 is mapped to 9, 5 is mapped to 17, and 10 is mapped to 37. So this would be a mapping diagram of our data. So we can have an input-output table, an XY table, a set of ordered pairs, or a map. Let's review our vocabulary. The domain is the set of all possible inputs for a relation. That would be this. Our range is the set of all possible outputs for a relation. That would be this. An input is a number in the domain of the relation. Again, all of these. And our output is a number in the range of a relation. So right here, these are all our range. So we call this the domain, and we call this the range. This is the end of the first part of our video on relations and functions.